söyleyeyim abi. Otoin network ከዚያገር ተለጥፏል።
ይሄን ጠርባፍ ነው እንደዚህ አይደለም ነው እኔ ምንም አለኝ ለምሳሌ ወልዷል ይሄን በቃ ካገኘ እኮ ይሰው ካላገኘ አላገኘ ፈርስት ታይማችን
Okay, let's start the last session. Let's start, and we have really really challenging projects. And the first one is Zizung YOON, from director of B-Space, Be Responsible Space, or how to call B-Space, and also Technical University of Berlin. This is a good address. It seems Technical University of Berlin is also a good address. To Manfred is not listening me. I am saying that Technical University of Berlin is a good address. It's probably a good address. Good, excellent. That's why Zizung is before it was a research fellow, and now he is following advices of SSTL and big gurus. He created a company. That's why he's a director of B-Space. And let's see, because somebody was putting here some presentations still. I don't understand why, how it's possible. Sorry. Okay, let's go.
All right. So let's go. My name is Zizung YOON. I'm going to talk about the crosslink mission in the S-band frequency domain. And since yesterday in the very morning, Mr. Yvonne Henri mentioned about the 4 key attributes which make small satellites even more sexy, like small, cheap, faster, and better. I want to talk about the attribute better, how to make small satellite systems or nano satellite systems even better in terms of functionality and capability. And of course there are different key technologies, but I think one of the key technologies to enhance the capability of those kind of small nanosatellite systems is the ability to build up a communication network out of many small communication nodes. And out of this network, the system could not only be like cheaper deployed, but by, for instance, commanding all the small communication nodes or terminals, we could almost in some future reach close real-time application which might be applicable for disaster management or security management, wherever we need very close revisit, not only revisit time, but also fast response time. So this is the idea or the motivation behind the mission SNet. And all the brief overview is given here in this one slide. So mission SNet is consisting of 4 nanosatellites, each nanosatellite with a mass of 8.5 kilogram and with an edge length of about 24 centimeters. So it's like, it's pretty small, but even though the core parameters for crosslink will be about 100 kilobit per second in data rate and bridging a distance up to 400 kilometers. And also the downlink will be done in about 1 Mbit per second or even more. So the entire system will be launched 2016, at the end of 2016, with, and all simultaneously separated from the launcher to maintain relatively a low relative drift to each other, and it will be a demonstration mission. So the main purpose is to demonstrate, since up to now, if you see in the history of those very small nanosatellite crosslink missions, there are very few which could successfully show this kind of crosslink capability. And the first one was done like 15 years ago by Surrey SSTL, the SNAP-1 mission. It was done on UHF frequency. The image you see over there is taken or was taken by the SNAP-1 nanosatellite, weighing about 6.5 kilogram. And very recently, just last year, the Canadian CANX 4 and 5, they showed on S-band basis a point-to-point crosslink capability. And also yesterday, we heard about the very interesting Edison mission from NASA, which will launch about 8 CubeSats at the end of this year, and also doing or performing crosslink on UHF band and downlink on S band. But all those missions, well, they work on very short distances, like some 10 kilometers, and very or relatively low data rates of about below 10 kilobit per second or some 10 kilobit per second. And what we want to demonstrate with our mission is that we want to show that those nanosatellites are capable of doing more in terms of some 100 kilometers distance or even some 100 kilobit per second. And not only point-to-point, which was done by the most missions so far, but really multi-point to multi-point routing. So, as the main mission statement, to be a demonstration mission, to show this kind of crosslink capability. Also, you want to verify the optimized communication protocols, since we will test different communication topologies and adapt different communication protocols to verify the test results in orbit with the real mission. And in our institute, we have some sort of history in developing this kind of communication technology, beginning from the very small S-band transmitter, which was developed in 2008 for CubeSats, and then the next step was developing S-band transmitter, a transceiver for a little bit bigger, like microsatellites for the 100 kilogram class, and the third step was to build the crosslink terminal optimized for nanosatellites with a total mass of 0.4 kilogram and a downlink data rate from nominal 1 Mbit per second up to 3 megabit per second.